Miss Collier explains!
Equivalent equations.
Our learning intention for today is to understand what it means for two equations to be equivalent, to be able to apply an operation to both sides of an equation to form an equivalent equation, and to be able to determine if two equations are equivalent by figuring out what operation has been applied to both sides. We will know we are successful when we can apply an operation to both sides of an equation and when we can show that two equations are equivalent. Equivalent equations. Now, if we think of the word equivalent, we can see the word equal within it. That means that two equations are actually equal to each other. So sometimes two equations can be giving us the exact same information even though they look a bit different. For example, if I do x plus 5 equals 14, that's actually the same as x plus 6 equals 15, or x plus 7 equals 16. All three of these equations are still telling me that x is equal to 9. They are all presenting the exact same information, they just look a bit different. So these are actually all equivalent equations. For each of these equations, we've just added 1 each time. But because we've done it to both sides of the equation, we haven't actually changed the value of x, and therefore we haven't actually changed the equation. We've just made it appear a little bit different. We can use this in order to solve equations. Sometimes it's good to imagine equations like a scale. That equal sign means that both sides have to be equal to each other or balanced. Here we can see x plus 5 equals 14. So on the one side we have x and 5 more, and on the other side we have 14. They are balanced, which means they are equal to each other. Now if I had these scales and I took 3 from both sides, I would end up with something like looks like this. X on one side plus 2 more, and 11 on the other side. Because I took 3 off both sides, my scales are remaining balanced and I haven't actually changed the value of x, or I haven't actually changed what the equation is telling us. If I go back to my original scale, and this time I add 1 to both sides, it's doing the same thing. Adding it to both sides means they remain balanced, and I haven't actually changed what the scales are showing. But now I have x plus 6 on the one side, and I have 15 on the other. Lastly, I can even do this with multiplication and division, as long as I'm doing them on both sides. In this example, I've taken my original equation and I've doubled it, or I've multiplied by 2, which means I've taken everything on the one side times by 2, and everything on the other side times by 2. So now I have 2x plus 10 equals 28. So as long as I'm doing it to both sides, they are remaining equal and I haven't actually changed the equation. So the thing to remember for algebra is an equation stays true when we do the same thing to both sides. We can do almost anything to an equation and it will remain true as long as we do it to both sides. All right, we know that two equations are equivalent if we can get from one equation to the other by taking any of these steps. Number 1, if we add the same number on both sides, or if we subtract the same number from both sides. If we multiply both sides by the same number, we will also have an equivalent equation. The only number we shouldn't multiply by is 0, and this is because even though the equation will remain true, all we'll have left is 0 equals 0, and that means we've wiped out the x, so we can't figure out what our pronumeral was. We can also divide both sides by the same number to get an equivalent equation. Except again, we shouldn't be dividing by 0, because that is actually mathematically impossible. Let's ask Siri what happens if we try to divide by 0. Hey Siri, what's 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad because you have no friends.
That was rude, Siri. That was rude. But she's right. Let's think of a number other than 0. Let's think of 9. I've got 9 cookies and I want to divide it into 0 piles. That's impossible. I can't put it into 0 piles because I'll always have that one pile of cookies. So dividing by 0 is impossible, so we cannot divide by 0 on both sides. Lastly, we can know that an equation is true if we literally just take the left-hand side and the right-hand side and swap them around, because the equal sign means that they're both equal, so it doesn't actually matter which way round we do it. All right, let's look at applying an operation to both sides. We need to make sure we read the question really carefully. It says, for each equation, find the result by applying the given operation to both sides and then simplify. So, A, first step is to write out the equation we have, which is 2 plus x equals 5. And now, in little square brackets, I'm writing the operation that I'm going to do. I'm going to do plus 4, and I've got to do it onto both sides. So now I like to rewrite my equation out, giving myself a little bit of extra room. And then I like to write in my new operation, and I prefer to do it in a different color just to highlight that I've done it on both sides. Added 4 on this side, added 4 on this side. Please note that these equal signs are in a line. They always have to be in a line straight down, okay? You have to make sure they line up. That's very important in maths, in algebra. Now that I've added to both sides, I now need to simplify, it says. So I've got to group any like terms, which here is my constants. I've got a 2 and a 4. 2 plus 4 is 6. I also know that my constant should be at the end, so I'm going to do, I've got my x, and I've got plus 6 equals 5 plus 4 equals 9. There we go. All right, let's try B. First step, write out my equation. 7x equals 10. And the operation that I'm doing is times 2 on both sides. First step, write my equals in a line. Then I'm going to write out the parts that I already have, giving myself a bit of room. New color, write in the operation that I'm doing. Times by 2, times by 2. Now simplify by doing the operation. 7x times 2. Well, 7 times 2 equals 14. 14x. And 10 times 2 is 20. So 14x equals 20. All right, C, we're trying a division. First step, write out the equation. 30 equals 20b. And the operation that I'm doing is divide by 10 on both sides. Write my equals sign. 30, 20b. New color, write in the operation. Divide by 10. Now I've got to simplify. 30 divided by 10 equals 3. 20 divided by 10 is 2. So I have 2b remaining. Lastly, D. 7q minus 4 equals 10. And I am adding 4 on both sides. Plus 4 on both sides. Write out my equals sign. Write out what I already have, giving myself some room. Add in my new operation using a new color. Now I have to simplify. Now I have negative 4 plus 4. They actually cancel out because negative 4 plus 4 is 0, but I don't ever have to write plus 0. So all I have left is 7q, and 10 plus 4 equals 14. And that is how I can add or subtract, multiply or divide using an operation on both sides. When you're about to do your work, please make sure you include all 3 lines of working. Write out your equation, add in your new operation, simplify. You try some. It may seem like a bit of a drag that I'm asking you to do all of these to write this instruction on the right hand side and to add it in different colors, but these are very good procedures that we need to practice, because once we get to solving equations we will need to do all of these steps. And so while we're learning about equivalent equations, we need to practice doing each of these steps. All right, let's quickly go through these answers. A, q plus 5 equals 8. Write out what I'm going to do to both sides. Rewrite out my problem. Add in plus 11 plus 11. Simplify. 5 plus 11 is 16, so q plus 16 equals 8 plus 11 is 19. All right, B. 7k equals 10, and I'm doing times 3 on both sides. 7k equals 10 times 3 times 3. 7 times 3 is 21k, and 10 times 3 is 30. C, 15 equals 25b, and I am dividing by 5 on both sides. Writing out my problem again. Remember, my divide needs to be underneath. And simplifying. 15 divided by 5 equals 3. 25 divided by 5 equals 5. Don't forget my b. Lastly, D. 9 plus 3b equals 8 plus 2a, and my operation is take 8 on both sides. I'm going to write it out again. 9 plus 3b, 8 plus 2a, take 8 on both sides. 9 take 8 is 1, so I've got 3b plus 1, and I'm putting my 2a at the front, and I've got 8 take 8 is 0, and I don't need to write in 0, so that's it. Now we're going to try and figure out how two equations are true by figuring out what operation has been done to both sides. The first step here is to write them above each other. A, 2x plus 10 equals 15, and 2x equals 5. I now need to figure out what operation did I do to both sides in order to do this. I notice that 2x hasn't changed, but the 10 has disappeared and 15 has turned into a 5. So I'm going to figure out that it was take 10 on both sides. That's all I have to do for those ones. All right, let's do B. Let's write them above each other. 5 equals 7 take x, above 10 equals 2, 7 take x. Now, if I'm looking at these two, I go from 5 to 10, which could be a plus 5. But if I look on the other side, it hasn't gone plus 5. What's happened on the right-hand side is that all of a sudden this 2 has appeared, which invisible math tells me it's times by 2. And if I look back on the left-hand side, 5 times 2 is 10. So it appears that both sides have been multiplied by 2. So this 5 times 2 would be 10. And on this side, the 7 take x has stayed the same, but the whole thing has been multiplied by 2. And lastly, C. I have 10 times b plus 3 equals 20, and I have b plus 3 equals 2. Now on the left-hand side, the b plus 3 has stayed the same, but the 10 has disappeared. Which it was times 10. So if times 10 has disappeared, I'm probably going to have to do the opposite of times 10, which is divide by 10. And on the right-hand side, I have 20 divided by 10 is 2. So that's correct. I've got divide by 10 on both sides. So for these questions where it says show these pairs of equations are equivalent by stating the operation, you need to figure out what is the operation they did from one to the other to prove that they are equivalent. You give some a try. All right, let's quickly check these answers. I've got 3a take 4 equals 10. 3a equals 14. On the left-hand side, the take 4 has disappeared, which means there's 4 more. And on the right-hand side, 10 plus 4 is 14. So plus 4 on both sides. B. 3r equals 5 take 4r, and I've got 6r equals 2, 5 take 4r. Well, this 2 on this right hand side tells me that it's been doubled, and if I look on the left hand side, 3 to 6, that's double, so we're going times by 2. Lastly, C. X take 7 equals 9 take 3x. X take 16 equals negative 3x. Well, I've got, my right hand side, the 9 has disappeared, so take 9. Everything else has stayed the same. On my left hand side, if I go negative 7 take 9, that's negative 16. So it's gone from negative 16 to negative 9. So that is take 9 on both sides. I hope now you can see that equations can be equivalent and be showing the exact same information as long as we've conducted the same operation to both sides. I hope you know how to do that and to apply an operation to both sides of an equation. I also hope that if you have two equivalent equations, you could look at them and figure out what operation has been applied to get from one to the other.